probability of the model. So he's seen all the possible sentences, like starting with "we like," and the word that's the most likely to appear is "you." And then you condition on "you," and you see, okay, from these ones, from these three words, "we like you," what's the next token or word that comes up? And a full stop is the most likely one. So underlying these models, there's this conditional distribution. So the probability of a model outputting word 3 given "we like" as an input. And when you see the temperature parameter, this is also related to this sampling behavior. The temperature comes from a statistical physics background, but basically it controls how much the model will rely on the most likely words, or if there's some entropy that allows it to explore less likely scenarios. So something that we also observe in practice a lot is if you had mute. Mute. Hello? Maybe from here? Someone is hallucinating?
I think we're maybe I was an iPad.
Let's try. Okay. So, yeah, sorry. You think it's this?
No, I think we're done.
Okay, awesome. So the temperature parameter, as you increase it, you allow the model to explore less likely scenarios. And this will also correlate a bit with hallucinations. There's also an important concept here. Hallucination snowballs. So one behavior that was observed in models, and this is something that you can also see in practice. If you ask a model, so the examples here is this number a prime number? It will say no, and it will explain it why. But if you ask a more open question, it will say, it might answer that question and then double down on the mistake that it made. So on the other hand, if you see the model, if you, from the question, you already have the answer, kind of. So you have, was John P. Hale's alma mater, University of Pennsylvania. The model more accurately will answer the question. So it's able to identify false claims better from the question than just an open answer. And what's at stake here is this concept of snowballing. So if the model will make a mistake in the beginning, it's very likely that we'll double down on that mistake and just make sure that the whole sentence will be coherent still, because it's still exploring that space of the distribution. So here the example is, who is the best football player? Roger Federer, and then it starts compiling some information that has nothing to do with it, with Roger Federer, but answers the question still, because this is still a likely output based on the original prompt. I'll keep this superficial. I wanted to bring some theoretical concepts, but I'll explain it very briefly. So this is a result, a recent result on how LLMs behave related to prompting. And there's a dynamical system behind it that was applied to self-attention, the behavior, the architectures, the core mechanism for transformer architectures. And the basic insight here is that for arbitrary facts, so facts that the model has seen before, but not very representative. So maybe if you have a person that you know that has some information in the internet, but it's not super widespread, the likelihood of hallucinating over it, it's very likely. So the results are actually that they're statistically unavoidable. So to answer the question, how much prompting impacts, it impacts a lot, and you'll see this with the last presentation. But in my opinion, it's not enough, and we need to add new information. This is what motivates the two types of strategies. So what affects, this is a bit of a summary of what affects hallucinations. So the first one is the statistics of the training data, the kind of examples that was seen. So if you have a foundation model from Europe, it will have different statistics than one from Asia, just due to the data that was seen, the model architectures and the training schedule. So there's, as the models progress, there's different ways that they'll interact with this data. And at the end of it, the words that are chosen in the prompt, because these will guide the behavior of the model. And the second and third point is also what allows us to motivate the two suggestions to fix this problem. So the first one is to tackling directly the architecture and the model. And the second one is a way to give more information to the prompt, to the model, so that it's able to answer the questions more accurately. There's also two types of hallucinations that you should be aware of. The first one is, so ones where the model won't have information. So the first type of hallucination I was talking about is maybe it's not representative enough. But in this case, there's no way when you ask a question, the model will have information on it. So these are also some of the most relevant topics for business use cases, because data is being collected by customers in the business setting, and things will develop. And for specific use cases, the models just don't have the information there. So there's a need to tackle these specific types of hallucinations. So now I'll go to the first type of mitigation we have, and it's fine-tuning. Who has heard of fine-tuning? Okay, I'll also keep it brief. So when you train a model, you fix its parameters, right? And then you have a new subset of data. To fine-tune a model, you basically have different strategies to, based on the original model, slightly alter the parameters of this model in a way that it captures this new information. When we talk about the world of large language models, the first thing that we should be aware of is the computational requirements that we have. So fine-tuning a model, like traditionally with transfer learning, where you freeze some of the layers and then you backpropagate all of the information to the parameters based on the data. This is not scalable. So, and this is also the first type of adaptive behavior we have. The way to mitigate this is through efficient parameter fine-tuning. And there's three core ways to do this. The first one is adaptive behavior, where at the end of the model, we'll add some of a set of parameters that will allow the model to capture new information. There's a lot of different ways to do this, but the most common one is directly in the transformer architecture block. So you have one of the recurrent layers. You add some of a few non-linear units there that improve the way that the model will be able to capture information. Another way to do this is through reparameterization, and this is the way that I think most people saw this in practice. It's through low rank optimization. So the core example is LoRa. I'll also get a bit into that. And the goal here is to understand that a foundation model, as it was trained with a lot of different data, people realized that there's sub-networks inside of that model. And the key insight is if there's sub-networks for each model, there's also sub-optimizations that you can do for learning a new set of parameters. So if you take the original network, you get another matrix that represents the change from the original model to a new model. And this can also be a low rank matrix. I'll get a bit into this. This, I think, was a bit high level and not that many details. The last one, I think it's also some of the most interesting one, because I think it's still in the beginning of the research that's being done here, but it's a way to select the most important parameters of the network. So some that might not be used, might not be used. And one way to do it is just check the magnitude of the parameters. Check the smallest ones, and then freeze all the others and update the model for those. There's also new ways to do this. There's a few strategies here where we condition these parameters on specific types of data. So for example, one way to do it is you fine-tune a model based on a specific type of data, and then you see for that use case, how much is which parameters are changing the most. And then these are the ones that you focus. You selectively close all the others, you freeze the others, and you focus your fine-tuning on those. And this allows you to have a much more efficient way to train the model without catastrophic forgetting. So a way the model won't lose everything that it already learned. So I'll leave additive and selective away, but I'll focus a bit on reparameterized. So the core here is LoRa, low rank optimization. So we start with a pre-trained model. So a pre-trained model can be looked at as just a matrix of weights. And you take this matrix of weights and you understand that there's a low rank version of these weights. So from linear algebra, we can understand that any matrix, given some constraints, can be represented as the multiplication of two other matrices, so A and B in this case. So what we look at in this setting is, instead of optimizing directly the original matrix, the pre-trained model, we only optimize A and B as a smaller version of that. And we can do this as an incremental update over this much lower dimensional space, which makes this much more efficient and also allows for some very interesting applications. So the way that we can deploy this in practice, and this is why it's so widespread, is that for a lot of business applications, we can keep one of the large foundational model, the one that's very big in a server container somewhere else. And then for each business case that you have, or each fine-tune LLM that you want to deploy, you fine-tune this low-rank trainable matrices. So this allows you to have all of this flexibility and a lot of inference time parallelization. I'll skip this a bit. So QLoRa, it's a version of LoRa. It's not really a version of LoRa, but it's a way to quantize models that relies on LoRa. And this is also something that if you want to deploy models in practice, you should definitely look at this, because it's one of the not most recent, it's a paper from last year, but it's a very important way to make sure you can run these in small GPUs. I also wanted to show you some basic code. This is how we work at ETHEREAL. There's a PyTorch module, not module, but a library built on top of PyTorch, which is TorchTune. So who knows PyTorch here? So, okay, enough that I dedicate some time here. You look at a tunable model here as it's exactly the same type of NNN module that would have on PyTorch, and you just add the specific kind of quantization or fine-tuning based on these low-rank options. And at the end, you just have this LoRa model as the final thing that you're working with. So it's very, very straightforward. And I also want to give you some hints. So if you're interested in this topic, take a look at some of these methods. So QA LoRa is built on top of LoRa and QLoRa. So it's a faster way to do the quantization. Fast LoRa, also faster way to implement LoRa. And then one of the biggest issues with LoRa is that it's very prone to overfitting. So overfitting means that you overfit to the small sample that you saw, and then some new examples come in and the model will fail. And these two options, Dora and BioLoRa, are very strong, especially Dora. It's a model from NVIDIA, recent one. Okay, so going back, this was a bit technical, but I just wanted to also give some insights to how you should use these models in fine-tuning. And the first consideration is data efficiency. So you should look at how many paired samples, input, output you have to train one of these models. So it's one of these models that you need to have question, answer, or document summary, anything that's insightful enough. And depending on the use case, this might be large or not so large. I've heard people using only 20 examples. In practice, I haven't seen that in my side, but you should test it, especially as you try to see in practice how the models behave. And also, it's very important, and this is also something I don't really advise too much, to use fine-tuning as a way to build a business value, because data will change recurrently, like very, very fast. So if you rely too much on fine-tuning, the cost will go much higher than probably having another type of solutions that I'll show afterwards. Computational resources, it's getting cheaper, especially with quantization. We can get away with just a few GPUs, but you still need to have GPUs. There's cloud services, you can use those, but it relies a lot on these computational resources. Some use cases that I also see as valuable from our side at ETHEREAL. Capturing voice of an organization or an individual. If you have like someone that has a very specific way of talking, these models will capture it very nicely. If you have specific ways of interacting with your data, this is also very interesting way to use it. And at the end, and this is something that we're now also exploring, is if you have a lot of LLMs that are doing specific things connected one to another, fine-tuning these models for specific tasks is also of value and something that you should definitely look at. Now I go to the second type of solution. It's retrieval augmented generation. And this is the simplest way I found of explaining this. So you start with unstructured data. So any sort of documents, images, movies, YouTube videos, podcasts, and you have to find a way to structure this into retrievable information. By retrievable information, I mean building blocks that you can then retrieve when a query comes in. Because the goal here is to find for a specific query, what are the sets of facts that will help the model answer this question. And it doesn't matter if the model has seen this information before. As I showed you in the beginning of the presentation, even if the models saw it before, this will help mitigate hallucinations. And it's probably this thing in our use case, in our solution, that we've seen the best demonstrated value compared to anything else. And there's a few challenges that I want to talk about. I'll briefly talk about a few and focus on three. But it's basically how to structure the retrievable information and how to perform the information retrieval. There's a lot to talk about on the information retrieval that I'll only focus on the dense retrieval because it's what highlights a lot of the other methods. But if you have questions, I can always come to me and I'll give you some insights here of what we've done. But from retrievable information, one of the things that we noticed that's the core for these processes is document processing or videos processing, podcasts processing. If you start with very strong data curation processes, the process will be much easier. And from then on, you have a process of identifying the building blocks. This is what I call chunking, or what people call chunking. I also call it aggregation. Depends on how you look at it. And then building on these small pieces of information, what we can do is build structures on top of it. So instead of working directly with the facts that you extracted, you can build a hierarchy on top of it. I'll also show you some examples of this. Then on the information retrieval, one thing that I think it's very valuable is restructuring your query. So just putting the query directly won't give you the best results. Just pure rewriting it from a question to a sentence will already help, but there's a lot of ways to do this. And especially if you have multiple questions in the same query, you should probably decompose it and send it to the information retrieval pipeline separately. Dense retrieval again to get into, but you can think of dense retrieval as the new kid in the block that relies on neural networks, and sparse retrieval. So dense retrieval is also vector search. Hybrid sparse retrieval relies on these older search methods. A lot of what Google uses to power Google search, for example. What's semantic retrieval? Semantic retrieval is basically you take a document, you take a neural network, and the neural network will be able to create a feature vector. A feature vector is just a mathematical representation of the information in these documents, in these texts, in these images, in these videos. And these vectors will have a representation in these very high dimensional space. And the goal here is to understand, is this vector very similar to this other vector from a different place? And this is the way that this is the method that we use to build most of the search algorithms based on dense search. So the first thing people talk about when they talk about semantic distance is the cosine similarity, but this is highly tied to the current contrastive learning based approach. So most of the models are trained with a specific type of training, and the cosine similarity is what works the most, but you should test other different ways of measuring this distance. So what's dense search then? Dense search is you take all of these facts from all of your data set, and this is something that we plotted. So for the ones that know, this is just a TSNE plot of a set of documents that we had. So each document will have its facts, and then you see for a query in red, what's the closest vector, and this is what we retrieve to power the search, to power the LLM. Now I go to chunking and aggregation. So the insight here is if you start with very structured data, the way to go is aggregation. And the thought process here is you start with structured sentences, paragraphs, sections in videos, sections in a HTML file. All of these things will have an inherent structure that it's easier to absorb for us to structure the information retrieval than to start with text and find a way to chunk it. So starting with unstructured and then chunking it, it's harder than starting with structured and then trying to combine it. And this is a lot of what we've seen in terms of our processes. We start with a document and aggregating it into what's meaningful makes more sense than trying to break it down. And the one way to do this is the high level way to do it, is to semantic aggregation. So using the concept I showed before on cosine similarity or semantic distance, you check for the first chunk, for the first block, is the second block close enough to it? So is it semantically related? Is it related enough that it should be a single building block? So you can think in a text, is the first paragraph highly related to the second paragraph? And as you start building these, it will make it will inherently find a semantic structure in your data, because you're using the semantic information to identify what should be together or not. One thing that you should be aware here, and I think it's one thing that I don't think people talk too much about this, but I think it's highly relevant to the way that chunking is done, is how much data are you adding when you combine the chunks? How big should your chunk be so that it still has enough information? So as you start with a very specific sentence, like I'm walking the dog, and I start adding it in the forest tomorrow morning with my friends, the information is kind of diluted. So if I'm now searching I'm searching with a query, what am I doing? What am I doing with my dog? The I'm walking with a dog will have a much higher answer, retrieval score than the second sentence. And the idea here is, like, when you start with these paragraphs and you start combining them, or when you start with a video and you try to identify the frames that you should break them, you should be aware of the whole information spread. So you want to build a set of chunks that's still meaningful. This is the last technical thing that I'll mention. It's just a method that was developed. We've tested it a lot. It works relatively well out of the box. And the idea here is you start still with the text chunks, but you cluster them with a semantic distance. So you'll find your building blocks that are related to each other, but you completely forget about the order. So you lose the syntax, but you keep the semantic meaning. And then you summarize these blocks into summaries. And these are the summaries that you then use to search. And this is an automatic process of building a tree architecture. So this is when I was talking about high-level structures. This is one way to build a higher level structures. There's also a paper from Microsoft, I think from this year still, GraphRag. I think they also implemented it in Azure, where they build a graph structure instead of a tree structure. We're also exploring this. I think it's not the cleanest way to do it, the way that they implemented it, but it's graph structures are inherently easier to navigate than just the semantic vector search or sparse search. So now after all of these technical details, should you use it or not? So I think the key question here is, how good is your curation pipeline? If you start with documents and you just scrape all of the text and you put it in a chunker and you try to do vector search, I think you're going to get a very disappointing result. So I think the first question you should ask yourself is, do you have a curated or structured data set, or do I have a pipeline to process it? And then the query itself. So if you know that from use case to use case, your queries are going to change a lot, this also affects the way that the whole experience will behave. So it's very important. So all of these parameters will be optimized for a specific data set. So as you change from more dense documents or more sparse documents or more connected documents with more topics, these things will impact the way that you do the search. The final thing is just the data set size. And what I think is the cutoff is from 1 million data points, you should start thinking of fine-tuning your own model. Below that, maybe in the 100Ks, but it really depends on the use case. The final thing is also a tiny bit of information of what we do at UTHEREAL. What we realize as we're building all of these different use cases is that there's a ton of optimizations that you need to do. So what we came up with is you take this unstructured data, your documents, your videos, and you capture, we call it signature features, but there's insights that you get from the data, the number of documents, the density, the sparsity, the entropy levels of the information, and you capture these as signals to guide your optimization procedure. So you say like, this pipeline should have this type of chunking, this type of hierarchy in the graph structure, all of these different things. And you just train a model to do this. And this is what we found as valuable. If you have ideas here, you want to know a bit more of how we do it, we can also talk about it. And this is it. Thank you. I think I went a bit over time. No, still have time. So if you have questions, I'm very open. Yeah.
I've also seen that one being used, and I'm still confused why people use that instead of actual distances.
So this is tied to the, so what's behind this is this neural network. This neural network was trained most likely with a type of method called contrastive learning. Contrastive learning uses cosine similarity as a way to optimize the process. And that's, if you train a model with cosine similarity instead of what you're saying, the L2 norm or whatever, Euclidean distance, whatever you can call it, you'll see that it aligns better. So that's pretty much the reason. I also have some doubts on what's the best way to do it. No, sorry? That's...
models in general. We use normalized Gaussian noise.
So I don't know if you heard the answer, but this is why you should use cosine similarity as a distance for in practice when you. So your answer is not just for search; is also why you should use it to train, right? Yeah. Yeah, but there's so much work that's been done here. Part of my research was also in this topic, and for example, just if you're interested in this, I'll just drop it. There's statistical methods that have a lot stronger guarantees. One of them is the MMD, maximum mean distance. And this is the gold standard for distances over vectors. Yeah.
Maybe a less technical question. You said before in the presentation that it's not statistically possible to avoid hallucinations.
To what, sorry?
To avoid hallucinations.
Yeah.
So always when the data is generated, there is always hallucination. So I'm just wondering, what is your view on, let's say we stay at image generation. When we have the images are generated and the new models are retrained with the images, and you have real images and also AI generated images, then it's always, there will be even more and more hallucinations. They will accumulate over time.
Yeah.
So it's a loose game. So what do you think about that? And if it makes sense to label AI data and really strictly separate the AI data with the real data, because that probably would make sense, because if we would merge it more and more in the future, then it will be even more hallucinations.
Yeah, that's a very insightful point. So this is also something I completely agree. So there's two things I can tell you of my personal thoughts here. The first one is like, in general for humanity, we should do this, because as you pollute more and more the data online. So for example, one of the biggest assets for training these models is, for example, Reddit, because it's all conversations. Yeah. But nowadays, this is very polluted data. So it's almost like if you have your own forum from the 2000s, this is more relevant than Reddit. So this is the first thing. And the second thing is also for business use cases, if you have data that you have yourself, this becomes gold in a sense, because this is unpolluted data, like books, documents, highly structured data, because even when you think it's not that people are just generating a book, is that I'm sending an email and probably using ChatGPT, and some worker in a factory using ChatGPT to generate a document that will be used by the whole organization. So there's this pollution process that we almost are not aware of. Yeah.
So it will be even more and more hallucinations in the future.
I think there's more hallucinations. I don't know about hallucinations, but the quality of the data is going to erode.
If you're using the same data, you're actually pruning the algorithm in the direction that it always comes with similar solutions. It's not coming with hallucination. Hallucinations, but in this case, would be creativity. Yep. In kind of like it's going out of context and bringing this stuff, kind of stuff. And if you're training on data which has been generated with AI, then you're basically bringing the algorithm to statistically always give the same answers.
Basically, the answers are going to be worse and worse.
Or the same. Be more plagiarized, so to say.
That's true. Yeah, it could also be.
Okay, last question.
Thank you for the presentation. It was technical and light in the same time. That's pretty tough. So my question is going to be just applied AI perspective. I see a lot of passions in the theory. I'm more into application. For RAG chunking, you said you have experimented that the technique of using the structure, inherited structure, is better. I generally don't use it because I'm worried different sizes could lead to different probability of distances. I use just I just use chunking. So did you do any comparison for that? Question 2 is also about RAG. I generally use buffer zone. It's a term I came up with. I don't know what the actual best practice is, just to keep between the chunks. Have you guys have any experiments? And finally, you mentioned graph RAG. You seem a bit doubtful about it. I've never experimented with it yet. Do you guys have any insights on that? Thank you.
Okay, let me see if I can go for all of them. So the first one is the just basic chunking arbitrarily. So to decide the size, I think all chunks shouldn't be the same size. There's different sizes, like you should optimize the size based on the kind of, so one chunk should be 100 words, the other one should be something else. This should be optimized based on that chunk itself. And from why I see like the structure of the information coming in is just, we put a lot of time creating nice text, right? We set up the paragraphs, we set up the sections, these are meaningful. I think throwing it away makes the problem harder for ourselves. And solving it the other way, I think it's almost impossible, especially when you rely on like OCR that doesn't work, and we had to build our own OCR to fix some of these problems, but a lot of it is tied to the quality of the data. The second question was the overlap, right? So the overlap is something that you could use. What we also do is when we get the title, for example, for a section, adding that title to the subsections is also meaningful. It's almost getting this, when it's helping that chunk to be more informative. And it's kind of what you're also trying to do. It's like these neighborhoods. If it fails, you have the backup that the second one will have it. So it's a two-way street. Like you're polluting the chunk, but at the same time relying on it being polluted as a way to solve the problem. We don't do it, but yeah, it's almost a trade-off. And what was the last one? GraphRag. So what I don't like about GraphRag is the way that they do the graph. So it's based on this community detection algorithms to identify the structures of the documents or whatever they use. And here, I think there's better ways to do it. So just from a semantic perspective, there's better ways to structure beyond entities and names and all of that. Thank you very much. I'll close off.
Okay, thank you. So if anyone wants to grab another beer, go quickly to the toilet. We have 2 minutes before we switch the microphone. So feel free, just quickly, and we can go to another session where Ferdinand is going to talk us a little bit about some product usages of the AI.
Mic check.
Okay, let's get back. We'll be starting in a minute, so please sit slowly as we'll be starting, and Ferdinand will walk us through of the role of the AI in the second-hand marketplace.
Zoom call, yes. So welcome back from the toilet, from the bar, or wherever you're coming from. I don't know if you ever felt like the dumbest person in the room, but after João kept asking, anybody know Laura, Clara, and Dora? First thing I could think of was Dora the Explorer or something like that. But if your hand stayed down when João asked, do you know what torch tune is and stuff like that, I think this talk might be for you, because I'm far away from being as technically versatile as you are with all of these tools. But nonetheless, I will try to make it interesting, because I'm a product manager, trained as a communication designer, have been coding simple, stupid websites all my life. And now just recently, I gotta make a confession, started being interested in AI because I always had kind of a trauma of these shitty chatbots which never did what I wanted. And then I kind of said, okay, AI, yeah, it'll pass. But I think this time it's different. So I hope you don't see any similarity between the guy standing in front of here. But I actually forgot to make a title slide. So it was like 11 p.m. at night, and I was still busy doing the slides. And just, yeah, I think 5 minutes before this presentation, I saw, I don't have a title slide. So I think that's what Beekeeper looks like at a town hall, not hope the CEO isn't here in the room. So who am I? I'm Ferdinand. I'm a product manager for Ricardo, which is part of Swiss Marketplace Group, which also brands like Tutti and Anibis also belong to us. So we have quite a strong foot when it comes to the second-hand marketplace in Switzerland. If you have any questions, whatever, also display some of my contact details at the end. I think that's the cool thing around these meetups, the people that you meet. You know, maybe if it's just one or two conversations, I never leave dumber. I always leave with a bit more knowledge afterwards. Now you know why this bar stool stands here. I was told in a rhetoric course, you get a bar stool when you want to do storytelling. So now I want to take you back to the days of when I was maybe like a sound that Stoneman made when they hit their foot on something. AI was not really a thing. So here's one narrow way to look at human history. After thousands of years of compounding scientific discovery and technological process, we as humans have found a way how to melt sand, add some impurities, and then we arrange this with marveling precision and do that at an extraordinarily tiny scale, run energy through that, and end up with systems capable of creating increasingly capable artificial intelligence. That was a quote from the blog of Sam Altman, where I thought I gotta bring that in a presentation because it's actually quite crazy what we were able to do with this technology. And this is how we use it. So generate a photo of a fun tech meetup in Zurich where there is a presentation about AI. I mean, I admire the density of dudes in this room. And I must say, we gotta pay respect to the dedication of this guy bringing his home office setup to a meetup. Also, they somehow figured out how to build a pedestal on top of the Limmat. I mean, sick event location, but this is what most people think about when we're now talking about AI. I want to tell you how AI actually matters for second-hand marketplaces. Not just marketplaces where you're buying all of your new stuff, but I'm talking about marketplaces where you have people like you, want to sell something, want to buy something, and ideally it has been used before, it has a life before, and you're using a marketplace for that. So essentially, we have way too many stuff in our homes, and it might be a luxury problem, but when you walk through your living room and you have a look at all of these items, I'm lucky that this kind of looks like a living room because I can take this. Usually that's the moment when somebody picks something up and breaks it during a presentation, but here's something like a nice frame, there's a mug, there's all of these things standing around. And you never know, does anybody want that? What's that even worth? I have to create a description, I have to create a title, I have to make photos of it. Oh, it's 6 p.m., I have bad lighting, now it doesn't really look nice, I'll do it tomorrow. Meaning, I'll never do it. So, you see, there's a lot of difficulties when it comes to the pure specs of a product. What's the condition of something? What's the price that I can ask for it? Then I have to ship it. Maybe somebody's going to come and pick it up. I have to be at home. Authenticity is a huge problem. There's some scammers that are selling you stuff where, okay, looks like a real watch, but is it really a real watch? Counterfeit products. And then, of course, you have to take photos of it, and then you have to be creative and write a description. There was a survey done by the Zürich University of Applied Arts, ZHAW, of around about 600 companies in Switzerland, where they were asking, how is AI actually currently used at your company? And the number one use case, together with the second line here, is we do translations and we generate product information. And then there's a long break, and then some generate photos and videos where I'm not quite sure what is done with that. Maybe just making sure that you have a transparent background or have the product look nice. But then there's search supported by AI, filtering and so on, product recommendations, customer support, personalization. That's the trends that how people, especially marketplaces in Switzerland, are using AI at the moment. It's interesting when we have a look at what is currently being developed, what is in the making, what's where do marketplaces want to go towards? And the number one thing is search, followed by operational efforts like customer support, product recommendations, and then also stuff like SEO, where you have automatically generated product information text, and all of this manual labor being automated. Then we have targeted marketing, personalization, and just at the end, generating product information, which for some still seems to be new. And every single company more or less said that they have a lack of know-how and specialist knowledge that makes it difficult to find use cases that actually have a tangible business impact. So I think all of you in the room right here, I think you have no shortage of jobs when it comes to this topic, but it's really hard for somebody to know what are even the possibilities if you never try around and doing something with AI. So at a hackathon at Ricardo, there was a team that presented an idea that started thinking about what if you could find secondhand pieces from the world around you? How would that look like? I mean, we have some applications already when it comes to Google Lens, for example, which you know. And we started asking ourselves, so one of the things that actually drives our company is something that we call the Ricardo reflex, which means that every time that you buy something new, there's lots of things which you can buy new. We want to establish that people ask themselves, couldn't I buy that secondhand? Because usually the items look just the same way after 3 months. And here, we just want to make that easy. And maybe you saw, like last year, we invested quite a lot into fashion campaigns when it comes to Ricardo. And if you, I don't know, I'm looking for something like really special what somebody's wearing. Let's go with your gray long sleeve. Not outlandish, but maybe I like the texture, maybe I like the fabric, I like the fit or whatever, and I want to find something similar. How would I look for that? I would say like, okay, cotton material, long sleeve, red, and then somehow go through 35,000 search results, but that's really difficult. So we came up with 2 use cases. One of them is being able to snap a photo, and one of them is being able to upload a screenshot. Both of them apply to if you're buying something or if you're selling something. So just to give you the promotional teaser, and I'll follow it up with a live example.
Heute verrate ich euch, was ich mache, wenn ich ein Piece bei jemandem sehe, das mir mega gut gefällt. Ich mache einfach ein Foto mit Ricardo AI und schon sehe ich Angebote mit ähnlichen Secondhand Pieces. Very easy. Heute verrate ich euch, was ich mache, wenn ich ein...
That was use case number 1, snapping a photo, uploading a screenshot, tension.
Dann mache ich jetzt einen Screenshot und mit Ricardo AI klatschen offen und es bildet dir ganz ähnliche Pieces in no time. So bin ich beispielsweise zu dieser wunderschönen Lederjacke gekommen. Hast du schon mal ein Piece?
Okay, Ferdinand, looks nice, cool promotional video, but let's see it in action. If you saw me walking around previously and looking at you in a weird way, that was because I was looking for significant items where I could challenge our AI with. And I'm going to join this call. Yeah, that works. So I actually saw you have a cool bag, cool handbag, where there's like a pattern on top of it. So I want to find something similar because I like that bag. So I am going to snap a photo of this bag. And what you now see is a list of products which seem to have some kind of embroidering. I don't know the brand of it, and we're always looking like for similar items. It seems to really recognize the embroidering somehow. There's similar articles, sometimes the same articles if it's like a really widespread article. Is it like some kind of custom thing, or can you buy it like everywhere? Okay, I think I found the most unique item in the room. That's cool. So you see that when you want to buy something, you can actually, let me stop the screen share again. If you want to buy something, it's quite easy to find visually similar items. If you have some kind of brand logo on top of it, it's even easier. It even recognizes that. Stuff like if it's made from leather or if there's like some kind of special pattern on top of it, that's actually quite easy. And I think with that, we're making secondhand searchable. So if you ever go to some kind of Brockie and you find like a cool jacket, but there's like a tear inside of it, you can just take your phone, make a photo and see if you find something similar. Now let's have a look at the use case of if I want to sell something. So same procedure. I just changed the tab to sell, and I took something quite easy, just a case of AirPods. So I'm going to take a photo of that. And one thing that a lot of people are struggling with is, what could I actually sell this thing for? We have been in business for quite a while, so like over 20 years now, and we have lots of product data. So, I mean, we should be able to tell you what this thing is probably worth. I mean, AirPods are all across the place. Everybody's walking around with these little toothbrushes inside of their ears. And here I can see that, okay, maybe we're going into the realms of hallucination because it's anticipating something that this is generation 1. But the cool thing is, these are actually AirPods Pro. I don't know how it recognizes, but maybe it's like a shape of the case or something like that. And if I then go down, it's telling me I'm selling a used pair of Apple AirPods. They're in good condition, function perfectly. The sound quality is still great, and the noise cancellation works perfectly. There's some minor wear and tear on the charging case, comes with the original charging case and extra ear tips. So at the end, I never made a photo of that. It's just anticipating it. I still have to review it. But you see, I'm kind of getting there. And if I then say continue listing, I could create my listing, and it already takes the first image, which I just made as a starting point. And then I could just snap some more images and then complete my listing based on the inputs which I had there. As you can imagine, there are some challenges when it comes to this. One of those things is, how do you get people to have their aha moment? That moment when they try something out and realize it's actually better than they thought. At the beginning, I told you about this chatbot moment. I was traumatized by like all of these companies coming up with a bubble interrupting me with what I want to do. I give that chatbot a chance, and usually I have a failure rate of 90%. Here, it's kind of the same thing. We got to get people to try it out, to get their hands dirty, to snap a picture, and then realize that this is a really, really powerful tool that they can use to shop secondhand. And with that, how do you get people to try something? We still haven't found the answer. It's just a slow adoption that is happening. But people that use it, they actually really, really like it. Then data quality. That's the biggest problem that we have in secondhand marketplaces. We have hardly any standardized databases where we can just get data from a manufacturer, have all of the metadata be available, and then just make that searchable or use that as a training material for our AI. So usually our data is not structured, it's not consistent, and that is a challenge that we face. The other thing is bias in algorithms. You remember the picture of the cool event location on top of the limit that I showed you? I was talking about tech meetup, and the tech meetup was filled with only guys somehow, you know? These bias also happens that maybe we might favor certain users which tend to overprice their items. Maybe we have a look at certain products that we push to the front, which might not be favorable for the user. So also talking about fine-tuning and stuff like that, we gotta give the possibility for users to also then fine-tune their results and have different data points so that we can understand what people actually want. And then the other thing is, which we don't talk about that much, is the aspect of privacy, that people are clear what kind of data is actually used from them. I mean, we're learning what you like, and that's maybe personal information, you know? We started from being shocked that Google, with a few queries, knows your personality and your recommendations and what you like. Now, imagine you fire off 1,000 pictures of stuff you like. So there's lots of information that is being transmitted, and this is also something that remains a challenge in AI, in which we have to be thoughtful of. Now I'd like to come back to my story chair here, where you might remember at the beginning when I was talking about the melting of sand, adding some impurities, and then being able to create chips from that, run energy through it, and then end up with systems capable of creating increasingly capable of artificial intelligence. This ending up, it's not like some Bitcoin maximalists say like Bitcoin is inevitable, AI is inevitable. I think it is inevitable. It can be avoided. The thing is, ending up, it's nothing that would just happen. It happens with, and I'm pointing to one of the developers that actually built this, who came today, Cesar, here in the audience. This happens with exactly those kind of hackathons where you just try out things for 2 days and see if we can do something cool, and then follow through half a year later, half a year later, what can we do? And then just learn as a team. So yeah, we have to really try it out, and then this ending up will happen. And I think it's up to us to really try with this new technology, what useful things can we do? And I think secondhand is nice because, we have no information. We're trying to make lives easier and trying to get the circular economy going a bit faster. So I hope you are interested in Ricardo AI. You might try it out and shop secondhand if you can. That would be cool. So let's stay in touch if you want. Thanks. And now I'm curious for some questions, if you have any. I think you raised your hand first. You can wait for a mic. I don't know how many people are in the stream. 500? Biggest talk I ever did.
So I have an item. I don't know what it is. It's not my domain. So normally I would put it on your website, say, listen, I have an item, looks like. Here's the photo, have a look. Now I use your app. Take the photo, app says, oh, this is a Rolex. Cool, I have a Rolex. I use your text, put whatever you suggest there, sell it, and guess what? It's not a Rolex. Do you already have an experience with more unhappy customers because now the text suggests something what your item actually is not because it just looks like?
I think when it comes to authenticity of items, we usually have the people that know it's not real and they just try to fake it to make lots of money from it. But we also have people that don't know what it is, like you say, where they, I don't know, maybe a person died and they inherited a watch and they don't know, is that a real watch or not? I mean, it says Rolex on the dial. Let me just list it. I mean, should probably be like 3,000-4,000 francs. Let's see. In that case, we have other mechanisms of reversing such a transaction, and we can't fully avoid it. We do have moderators on the platform and also users that report listings. So usually you will have a lot of people that have like a search subscription for all kinds of watches. Back. And they will then report and say, well, this is not a real Rolex. And then it will get flagged to our customer support. And then they would take that listing down. And then they would be asked to give us like original receipts and invoices and like additional information until they can list again. When it comes to experiences, like how often does that happen? I personally do not know, but we could ask Cesar if he knows. Also not. I must say that the feature is also still like it's not like 90% of our users are using it, and we haven't even launched it on iOS yet. That is coming. So for iOS, you can snap a picture and you can sell at the moment, right? Yes. So buying is not still possible, but you can sell. And I think with iOS, which has the biggest share of our users, typical Switzerland thing, we will have also lots more knowledge and feedback on it.
Okay, thank you.
Thank you. Yeah, in the back.
Yeah, thank you for the presentation, Ferdinand. Great job. And Cesar, great job too. And the team, I know Cesar personally, so it's great to see you here. What other, can you share some other AI use cases you have at Ricardo at the moment? Because I could imagine, especially when it comes to fraud and people that try to use your platform to rip off other people, let's say like that. I mean, it could be very helpful, no? Are there use cases? Are you working on something? Can you share something?
Yeah, sure.
Yeah.
So fraud, yeah, is a big problem. I mean, anywhere where there's money to be made in an easy way, you attract people that have bad intentions. When it comes to fraud, we actually utilize pattern matching. So we have a lot of training knowledge where we know this is a fraudulent article, this is not a fraudulent article. And what we really, we for example, know that just by simple ways of things are written, or if somebody tries to take something off platform or has a URL or phone number in their description text or in a question or whatever, then that will get flagged and then we review it manually. But that is clearly a growth area of the future. So this, what you saw with optimizing customer support, making sure that you can have a better service for more people, faster response times, and be able to put a human in front of a case that really desires it and filter through the noise. That's something that we're really working on also as a growth target for the next 1 to 2 years.
Sorry, we have to cut here. I see the pizza is coming, so we just do the last presentation so it doesn't get too cold.
Yeah, just ask me afterwards. I'll still be around.
I think Ferdinand will be still around after.
Thank you.
Yep. Okay. So let's start with the last presentation. And there is a huge pressure on me because I see this pizza and I know it's getting colder and colder. And I still want to tell you something. So I'll try to go through this quite fast. Compared to Ferdinand, I will not be sitting. I still want to tell you sorry, but I was sitting already over 8 hours at work, so I'll just stand. Let's firstly start. My name is Michał Koźmiński. I'm principal software engineer here at Beekeeper. You can follow me on LinkedIn, Twitter, Medium. My name Michał Koźmiński, but I will also share later the QR code you can scan. Firstly, before we start, 2 words about Beekeeper. What is Beekeeper? Beekeeper is a product which tries to combine all of the tooling necessary for the frontline workers to make their work efficient. So we try to combine connectivity as well as the HR toolings specifically focused on the deskless people. For people who don't have a desk, who work mostly with the phone, and trying to give them access to the tooling where they actually perform work, which is not a desk work, but still they need access to the communication platform as well as the centralized platform for shifts, for communication, get information to documents. Couple of numbers about Beekeeper so you understand what kind of scale are we talking here about. We have over 500,000 weekly active users, 5 million chats are opened each month. There is a 150,000 posts written. We have 85% adoption rate for thousands of our customers, and we have 4 data centers. So whenever we talk about our scope, it's not a scope of a Google per se or Spotify or Netflix, but there is still a factor of it to it. And when I take you to a story, I want to take you back to 2023. We saw a rise of LLMs like GPT-3 from OpenAI, Llama from Meta, or BART from Google. And this LLM started to be more and more useful. We started to see a lot of use cases actually developed, companies using this successfully. And we really wanted to make sure that whenever we build something, we build the right thing. We wanted to make sure that it's really frontline workers focused, that we deliver something which users can trust. As you can imagine, frontline workers are really focusing on their work. They're doing the best they can. And we didn't want to now stress them with some untested technology, with something when they come back and they lose the trust. The AI or LLMs came to them as a zero trust thing. They didn't use it yet. Or maybe when they use it as a ChatGPT to write some kind of poem as people used. So whenever we do it something, we wanted to make sure that what we do is going to help them work. And on the other side, it's going to make sure that we not lose the trust. And the thing which we build, I lost one slide. The thing which we build is a chat summary. So chat summary was the idea that when people come from the work, when they are, for example, seasonal worker, or they only work part-time, they might see a chat with 5 of their colleagues. They see what's happening there. Is it really related to me? There was a huge idea that there was an overload of the information for the frontline workers who come to the work. They start to look, what do they have to do? And they see like 20 messages, some emails, maybe shift change, so on and so on. So we wanted to make sure that we can get them summary and tell them, is it relevant to you? Do you have to look at this chat? Or maybe you can just skip it, or maybe just give it a glimpse. So just that's what we wanted to do. And how did we implement it actually? So we firstly look on which model to choose. We had a couple of models to choose back then. There was from OpenAI, there was this GPT-3, there was Llama, there was BART from Google. And there was a new models coming out. So we felt a little bit, I know if some of you know this guy, Kierkegaard, one of the philosophers, and he had this idea of being lost in the infinity. Like there's so much choices in your life, you don't know what to choose and you're just paralyzed. And that was us. We look at the choices and was like, that's too much. We have to somehow find a quantitative way of knowing which model do we want to use, which is the best model. So we started to think how actually we can judge if the model is good or is it bad, or is it performing well for us? And we come up with this kind of star. The star is a funny star because whenever we think about the model, we think about speed, context length, quality, and a price. And the funny thing is, if the model is actually cheap, it's usually fast because they're usually a small model. But on the other side, it would be probably having a small context length and a poor quality. So based on these 4 parameters, we wanted to judge our models. So how did we evaluate models? We started with creating a set of 20 synthetic chats. These chats contained a perfect summary, which was handwritten by a person. And after that, we did a manual evaluation of the results from LLMs. We just look what LLM resulted as, which one is the best for us, so we can get this quality, because everything else was easy. We can get the price, we can get the speed, and we can get a context length just by looking at the technical specs. And then we try to a little bit adjust the results, but using some prompt engineering to see like if we can make it better. And let's do the math. How much did it take us? Let's assume that we need like 5 minutes per evaluation. We have 20 summaries, 1 hour 40 per model. I'm like, not bad. I mean, like if it's just one time off, fine. But then we have 3 models. Okay, 5 hours. That's not tragic. That's still just less than a 1 work day. But then we wanted to try different prompts. So we ended up with 8 different prompts, times 5, that's 40 hours. So pretty much the whole week of one person just checking it and making sure they will not make a mistake, they will not get tired, they will not start writing like, I don't like it, I love it, and just setting 1 or 5 randomly. That's not something we wanted to have. And then even better thing happened, new model came out. So we can just put everything to scratch, like, okay, this models don't work because now we have a Claude coming out, then we get a Llama 2 coming out. So even better, so 40 hours, we can completely trust us, probably 400 hours now. So we had a complete panic. Like, how do we now actually make sure that we can improve this? We can make sure that when the new model comes out, we can again validate that it's correct or not. So how do we stay on top of these changes? We wanted to create automated evaluation pipeline. And this pipeline used a mix of techniques, which resulted in an automated way of telling us, is this model performing good enough for us? Is this model better? Is this prompt better? Which one to use in the next deployment? And this we could do using combination of testing using LLMs as well as some classical methods. And I'm going to walk you through what kind of metrics we use and what kind of approach we had to actually validate something, which is not as easy as writing unit tests. There's no unit test you can write for the LLM because results would be always a little bit different. So some of the metrics we use. One of them is a compression ratio, quite easy. Next one, presence of action items. As I said, we wanted to do chat summary. So we wanted to see if there are action items related to the person who is actually reading right now the chat. Next one was lack of hallucinations, something João talked about. And then vector comparison, also something which we had there. So let's look a little bit on how it works. Here we have on the left side, I don't want you to even read it. That's a part of the chat message, and then we have a summary. So to get our compression ratio, that was quite easy. We have a Python script. We calculate all of the amount of words in the original chat. We calculate amount of words in the summary, and then we have a compression ratio. Do we want to have 5:1? Do we have a 4:1? Do we want to have 6:1? And give it like 10% of like a margin. So in case it goes a little bit out, like 5%, and nothing happens, still perfectly checked for us. Easy peasy. Next one, action items. Again, easy thing. We had 20 summaries of the chats, which are prepared as synthetic ones. So we know there are any action item related to the user. So the only thing we have to see is prior regex, if there are action items, because we knew from our predefined set if there are action items for this user or not. So we can do, if there are action items, it's a pass, there are no action item, fail, or the other way around, depending which user did we look on. But then it starts to be a little bit more funnier. We start to look on the hallucination detection. And how did we do summary hallucination detections? It is a little bit more interesting story. So we look at the summary, we took original chat, and we pushed everything to the LLM. And we ask, based on this theory, do you think that this summary stands? Answer yes or no. And this actually gave us really good results. The only thing we saw is like we have to use a model from a different family. So whenever we tested for hallucination happening on the OpenAI, we use Claude. Or if you use for Claude, we maybe use Llama. This way, the hallucination, there's a lower chance probability of actually hallucination happening in the same place twice. But the other thing which we did, we brought actual person. So 7% of our queries were actually sent to a real person. And then we compared the results that we actually drifted. And we see that they are not drifting. The people actually said similar amount of percentage of things were hallucination as LLMs. And if you want to look a little bit more about why did we choose 7%, I don't really want to include it right now. You can look at the sampling techniques from 1977, a very nice document which you can read actually how to correctly choose the percentage you have to send back to validate it by the person. And the last thing is we had a vector comparison. We have our perfect summary. So what we did is we embedded into embedding in the vector space our perfect summary, as well as the summaries we were getting from the LLM created for these chats. As you can see here, I did a very simple example. So what I did is the generic ones that this is the two perfectly written summaries. And then there is a one which is written in bullet points. So it's a completely different format, but the same content. And the other one is a falsified. So I changed a couple of things. I changed the dates, I changed the people, but the content, let's say like the format of the content was still the same. And as you can see, it's still further away from the bullet point one. So even if we change formatting a little bit of the summary, if it contains the same semantic idea about what's happened in this time, they will be closer in the space. So we actually could use it to detect if our summary is as close as possible semantically to the one which we consider a perfect one. So then we built up our leaderboard. We leaderboard looked quite simply. We had a model A, model B, and then we have a certain prompt depending on that. And then we said like, this is the best performing, this is worst performing, so on and so on. And then we can add the things like price to it and see like, maybe this one's performing just a little bit worse, but the price is twice cheaper, like 50% cheaper. So why not to use it? And this allowed us to actually, whenever the new model came out, whenever someone from the engineering team has like, oh, I have this great idea for the prompt engineering, how we can change the prompt, we could just put it into our pipeline, and literally 20 minutes later, we had a result like, oh, it makes sense, oh, it doesn't make sense to us, for example, to upgrade to GPT-4. That's what we saw. Like when the GPT-4 came out, we were like, let's see it. We looked at it. Yes, the results were better because it was better model, but they were marginally better than the GPT-3.5, and the price was like 4 times higher. So why would we pay for it? And that allowed us to actually make a reasonable decision. So 700-degree calculated which model do we choose. But we don't stop here. We want to improve. Yes, so let's improve the results even more. We started thinking about the fine-tuning. And like every single paper, every single blog post was saying like, you have to do fine-tuning. Fine-tuning is what all the cool kids are doing. Like we want to be cool kids too, don't we? But then we look like, oh, we need probably around 500 examples. We had 20 and that didn't work quite well. We tried to get 40, also not. Probably we can do a little bit less, but we felt like that might be something where we actually see like a real results. And we even look on the cheapest model, which was back then GPT-3.5 Turbo, and that would cost us almost $700 to fine tune just this model. And if we now want to have multiple models, we want to change it, each time paying $700, that would be something which we can work, especially on if we want to iterate very, very, very fast. Another problem we started to look is that we wanted to make sure that we can change it quite fast. So the other thing we started to look on is the prompt engineering. Here I did like a small comparison. What is the difference in prompt engineering and fine-tuning? And the one interesting thing is the flexibility. So after fine-tuning, model changes how it behaves, kind of permanently, because you change the model, so it will behave differently. Or with the prompt engineering, just change the prompt, it will behave again differently, cheaper. The other problem is we needed data. We needed quite a lot of data, and we wanted to make sure that the actual chat summaries are relatable to our customers. The problem we have, like, we just won't get data from our customer, telling like, hey, can we just train on your chats and see, like, do you like it? No, so probably we have to write chat summaries based on possible conversations which might happen between type of customers and industries we see. But are we right 100% sure that we're going to write the correct chats and correct summaries? Probably no. So we felt like, let's start to look into the prompt engineering and what else can we get to get even better results. And when we started to look on the our chat, probably every single time you use any single AI feature, you see this thing, basically thumbs up, thumbs down. When people say like, oh, I liked it or I didn't like it, this allows to actually then tell like, does this prompt, does this model perform well? But we want to get more, like, what does it give us thumbs down? Does it really mean that it was bad, that it hallucinated, that maybe users didn't like the content or maybe type how it was written? So what we add is like, whenever someone press thumbs down, we ask like, hey, what's your thoughts on summary? And we started to gather this information and actually pull them and read through them and see what users are writing. But again, that doesn't scale. You saw 4 million chats open every single month. Let's think that even 1% of these customers are going to use the summary, just 1%. And then 20% of them sends the feedback. We'll be drowning in just reading this and trying to catalog it. So again, we are like, okay, we are software engineers. We can automate it. Let's just spend some time and try to automate it. We know we have all of the puzzles somewhere there. We had a leaderboard already. We had an evaluation pipeline. We know some prompt engineering techniques. I really don't like the word prompt engineering, and then we had user feedback. We just needed to somehow pull it together. And this is what we came up with. We created a self-improving pipeline which actually updates the prompt as well as the models depending on the user feedback and self-mutates. So let me walk you through it. How does it work for us? Firstly, a big picture, how it works, and then we go into like drill down into this thing. As you can see, we have a scheduler. The scheduler will start. This allows us to actually run this on the time of the peak. So we don't have to pay extra for the processing power. We just run it on our Kubernetes cluster whenever it's off the peak. Then we fetch our baseline. Baseline is quite easy. We already calculated with our evaluator. We have a baseline. We know which model performs the best, which prompt performs the best for us. And then what we start to fetch is we fetch actually users' feedback. We fetch user feedback and we send it to our mutator. Mutator then tries to mutate the prompt to improve it, and then tries to evaluate it again to see if we improved. That's big picture, big overview about how it works, and we can see a little bit more in detail how it breaks down. Evaluator, we talked about it, just tries to quantify the results, get the string into some number, which I can then compare, create a reference points for us, and then is a base for the leaderboard. Mutator. Mutator is actually based on the very nice paper I can recommend you to read. It's called Self-Referral, Self-Improvement via Prompt Evolution. This is what we based it initially on. We kind of develop it a little bit more. Idea is what we take prompts and we try ask to LLM, can you actually mutate it for us? The only problem with that was we have to have idea to then evaluate, did it improve or not? Telling to LLM, please change this prompt is not a problem. The problem is if you would create 7,000 of them, and then you need to somehow evaluate if it improved the quality or not. But we already have an evaluator, so great, maybe we can reuse it. And we want to make sure that we are LLM agnostic. So we are not relying on a tooling which can only work on one type of LLMs, but we can deploy them to Mistral, we can deploy it on Claude, we can deploy it on whenever cloud we want, not only for the one. And how Mutator works is, Mutator has something called mutation prompt, and then we add initial prompt. That's the prompt which we are starting with to try to mutate. Then we have a thinking style, and that creates for us a new prompt. So let's look at the examples how the mutation prompt might look like. That's 3 of them. We have over 70 of them actually in our code base. Modify the following instructions creatively, giving some advice on how to solve it. Elaborate on the instructions, giving some detailed advice on how to do what it is wants, and if you were explaining it to a child. In one short sentence, here is how I would the best follow these instructions. And we just give it to this, we give it our prompt, and we say like, please mutate it. And that's exactly what we took from the paper. But then we're like, but we have this all of the user feedback, like they didn't mention anything. No one ever mentioned how we can incorporate users' feedback into that. So what we did is we wanted to include user feedback. So we added two new things. Instead of just having initial prompt, mutation prompt, thinking style, and new prompt, we actually added user feedback and the context. So this is an example of the prompt. What additional instructions would you give to someone to include this feedback into that instructions? So then, for example, we can see here, we take this example. That's a summary which was generated, quite long. And someone just wrote, summary long, I prefer bullet points. And thinking style, we did like, please think in steps. So applying the chain thinking. So prompt was create summary of the given conversation, summary to wrong, I prefer bullet points, and think in steps. And this is what LLM came up with. Create a summary of the given conversations using bullet points, keep it concise and highlight the key points. And this is the new summary. So you can see the results. Quite long one, way shorter. And user only said like, hey, I just want to have a bullet point. And they see evolution happening for them. But then we needed to make sure that we actually improved. So did we actually took the user feedback into account? Did the LLM change the prompt, mutated the prompt in such a way that now actually it works? So that's something we actually took from the NVIDIA NeMo guardrails. I don't know if anyone heard about guardrails from NVIDIA. Okay, not many people. Basically, what it's used to is to try to make sure that LLM stays on track. That's why the guardrails comes from. And they have like set of multiple prompts, highly recommend looking at, which you can use. And we took this prompt, where it's like, You're giving a task to identify if the hypothesis is in agreement with the context below. You only use the contents of the context and not rely on external knowledge. Answer with yes or no. Context, summary, hypothesis, and agreement. So what we did is like, we passed the new summary, we passed the user feedback, and we ask, is this hypothesis correct now? Should be now false because we have actually bullet points. So we try to evaluate and mutate prompts as long as possible. They did not pass the hypothesis. And if they passed, it means like we still have a problem here. So we have everything. You feel like now it's going to be great. Now we deploy it, we run it, we pull more and more data, and we see things going smoothly, nice, up. But then just whole metrics crash. The more data we got, the metrics completely crashed. I must say, like on this day, I was completely devastated. I spent like last couple of weeks, I would say even months, designing it and building it with the team, and then it just doesn't work. And we started to dig into it. Did we make some mistake? Did we implement something wrongly? Did we use some wrong prompts? Did we maybe make some stupid Python mistake by adding the results? No, that wasn't this. It actually seems like people are not in agreement together what they really want from summary. Like people don't really know what is a summary. Everyone has a different opinion. One person says like, it's too long. The other person says like, I just want to have information which are related to me. The next person is like, actually, I prefer a longer one because I want to know what my team is up to. And we try to like fit all of them together. We created this little small monster, which was like contradictory information into the prompt, which started to collapse all of the metrics. So we needed to somehow prevent degradation of the results. And we did it in quite a simple way. What we did is we started to bucket the user feedback. So we only mutated the prompts per user. This allowed us to even have a side effect where users were more keen to write the feedback. They write like, hey, I don't like it, please change it to be more informal. They come a week later, and it's like, oh, it's now less informal. Or maybe they change like, hey, I want to have informations also on a bigger picture, or maybe, as I said, like bullet points, and then we'll see the prompt as well as the product evolves with them, allowing that actually this feedback works for something. And that's something without us actually manually labor and checking everything, so on and so on. So we started to have improved user journey from comment to saving to database, processing, and then having a user actual feedback. So here are some of the resources which you can find, which we used as part of the development of the tool. And here I would like to thank you. And if you want to follow me, here are some links for my Medium and Twitter. Thank you so much. So any questions? I have to find Andrei is here. No, I need to find out. Someone has to basically, can you pass the microphone maybe to people who ask questions, if you could? You catch?
Thanks for the presentation. It was really cool as you go through the presentation, a lot of my questions were answered. I was like, oh, I'm going to ask this question. I was like, oh, no, okay, answered. And again,
happy to hear
but
that.
I have one at the end. Like, have you tried prompt injection? Like when user personalization is in place, usually the most common technique I know is prompt injection.
Mm-hmm.
You just have a standard prompt and then you inject user personalization techniques there.
Then, I mean, like that would probably work. We didn't try it because our initial idea was that we want to improve prompts for everyone. And the part of the feedback was just a side effect. Like we saw we have this data, we're like, why not? It's probably a couple of lines in the Python, doesn't cost us that much. Initial idea was to develop the base form and actually a base prompt and develop it, make it better and better.
Thanks.
How do you keep control of costs if you try to personalize those prompts? Like if you keep making them personal, you can't use techniques like prompt caching or whatever. You know, you'll be,
to be honest,
increasing overall tokens.
For us, even prompt caching wouldn't work because every single person does a different chat. Yeah, so if you try to see the chat, they might have a different idea about what is happening. So we cannot take the prompt and like results of it. Or
so you just accepted the costs.
Yeah, exactly.
Thank you. Very nice talk. Have you thought about incorporating guidelines or curated information, not from the user, but from other sources like we saw in the first presentation when they do the chunking, for example, documents, because there you may have a source of knowledge that it doesn't come directly from the user, but from a relevant source or the source that you can trust.
Yeah, that's a good question. I mean, like we really focused on that feature and actually summarizing the chat. So we wanted to make sure that only the content which the user did not see, plus some extra content for the reference, is referenced. But if someone, for example, sends a photo, we try to also add this information to the chat. So we basically, whenever there's a photo uploaded, we also try to describe it. What do you see on this photo? And then use it to inject it to the database. But if you send any document, you won't be able to chat to this document. There only be the information like someone sent a document, because it's only pure feature of chat summary. So we don't add any external information, just to not pollute information. Because what we also found is every single industry will understand certain abbreviations differently. And what we had to, for example, add is that some people would write I don't know, MVP, and they will mean completely different thing depending on the industry. So we couldn't rely on that. We also had to inject information to the prompt saying like, this is based on that industry. So it also knew what kind of additional informations are there, but we tried to avoid it to make sure that we don't pollute the chat, because it might take some information which are not there.
Thank you for the presentation and for organizing, by the way. Amazing to be here. One question more from the side of product management. What led you to refine the prompt for a summarization task? I mean, LLMs are pretty good at summarizing content in general. So did you measure the value add that the whole prompt refinement process brought?
Yes, so that's a great question. I mean, like generally LLMs are superb at summarizing. The problem is they just try to summarize as good as they can. And what we really need to make sure is like, if you Dave and there's conversation between like 3 of your colleagues, like Peter, Steve, and someone else, and they talk something which is not relatable completely to your job, it will just skip it. It will not summarize it. Like, please skip the content which is not really relevant to what your job is necessary to do. So we wanted to bring this factor into that and making sure that this is short to maybe summarize, like Peter and Jason had some discussion, but besides that, there's nothing really relevant for you, or maybe you're working in the healthcare and there was some case which is important. So that's something which we really wanted to look into, that the summary is more personalized and it is something which tells you the story and not just summarizes the whole chat. Okay,
one more.
Maybe one last question.
I think this is important for everyone. Please make this open source if possible, because it answers a lot of pain points. So I'm not sure how many number of hours you guys put into this, but
quite a lot. You can see my depression when you see everything went down, and I understand that I just wasted so much time of my life. Let's see. I mean, like that would be definitely amazing. I think like it still needs some polishing to kind of make sure that it's working correctly, but why not? I think it's a great idea.
Cool.
Awesome. Okay, last, and we done, and we go for pizza.
Thanks for the presentation. Do you have any data on the usage in your customer base? How heavily this feature is being used?
It's first of all, this feature is not really heavily used because it requires chat to be scrollable already for the user. So if someone comes in regularly, they don't really see it. We see a couple of % from the chats being used, because mostly people stay up to date. Is a certain percentage of people who only have this chat. But what we saw is the chats which were unopened with a lot of messages, people basically give up of them, kind of pop out. So that was a nice thing. Awesome. So thank you everyone for coming here. And I will invite you all for a pizza, which is waiting there. I hope it's still warm, as we still have some time and for some great networking. One more quick thing. If you want to talk on the next meetup, if you have any topic, please reach out at contact@zurichai.club. Just send the information what we want to talk about, and we are still looking for a speakers for our next meetup. So that's the last thing I wanted to let you guys know. Yeah, one second. I'll just close everything. Thank you. Let me just finish everything because I have to close the connection and everything. It just Marshall.